Let's review test 14 from last week. Remember to subscribe to my channel to get these videos right when they come out. First off, I want to say I had a couple of technical difficulties when grading test 14. So you might notice that the automatically graded score is very low. However, I did go through, I looked at all your answers, and I manually graded the rest of the answers that you'd given. I'm also going to post the answer key to the test on Jupiter Grades, so you should be able to check against that. And if you have any questions about my grading, let me know. Let's take a look at the mean, median, and mode for this test. Out of 60 possible points, the mean was 46.6, so a pretty solid C. The median was higher, 50.5 out of 60, which I was glad to see. Unfortunately, our mode was still an F. So although most of you guys did pretty well, those of you guys who are not doing so well, there are a few of you. So pay attention to this video and other ones, and come to my virtual office hours. All right, first I want to make a couple of quick comments about two of the problems here, and then we'll move on to four of them that I want to go a little more in depth to. So first off, number 3, when I asked you to write that set, K, with those numbers being elements of that set, there are two things that I was looking for that not everybody got. The first is curly brackets. You have to use curly brackets to indicate a set. It's just the way that it works. Second off, the other thing that I saw a lot of guys missed was that even though 2 is listed twice in the numbers there that they want to be elements of the set, when we're listing the elements of a set, each one only gets listed once, even if it appears multiple times there. It doesn't matter if my initial list has 2 one time or 500 times. It's still, just writing it there means that 2 is a member of the set. It doesn't tell us how many necessarily are in that initial list that we were given. All that it does is it tells us 2 is one of the things on that list. Next up, number 8. A number of you got right, but didn't put your answer in the correct format. So you might have lost a point there. I asked it for the answer as an ordered pair. So instead of writing x equals 11, y equals 3, you should have written it inside parentheses, right? Not curly brackets for a set, but parentheses for an ordered pair, 11, comma 3, your x value first, and then your y value. All right, let's take a look at a couple of these questions that I saw some bigger issues on. One of the things I saw some difficulties with were number 4 and then also number 1, the two questions that had to do with percent. So let's just look at number 4 because I think that's pretty indicative of some of the ways that people got confused. So the question here said that this guy got 72 pounds of honey. Hopefully you can see that. Probably can't. Anyway, he got 72 pounds of honey, and this was a 50% increase from last year. How many pounds did he get last year? Now, a lot of you saw 50%, you saw 72, and so you wrote 36 pounds as your answer. Be careful, though. If he got 36 pounds last year and then he got 72 this year, that's actually a 100% increase because it doubled. 100% increase is a doubling. So we got to be careful here. So the way that we should do this is we know that 75% is a 50% increase from last year. We're looking for what he got last year. So 75% is actually 150% of what he got last year. 150% of this number is 72, because last year he got 100% of the number that we're looking for, last year's number, and then a 50% increase. Then this year he got 150% of that. So it's actually only half as much more, not double. So if 150% of that number from last year is 72, that's 150% times the number. We can simplify 150% as 3 over 2 times x equals 72. Then we can divide by 3 over 2 on each side, and we'll end up by doing keep, change, flip. It'll be 72 times 2/3, 72 over 1 times 2/3. We can simplify here. 3 divided by 3 is 1. 72 divided by 3 is 24. 24 times 2 gives us 48 pounds that he got last year, not 36. And again, a way that you can check that is that doubling, which if he had 36 last year and 72 this year, that would be doubling. Doubling is a 100% increase, but here he only had a 50% increase. And then with question number 1, there were some similar things. There we had, I believe it was a 120% increase. So you're talking about, it's actually 220% of last year's numbers, not 120% of it. It's more than doubling. Okay, number 10, pretty quick explanation. Whenever you have these fractions inside fractions, as we saw when we were talking about negative exponents and manipulating them on fractions, when we move something between the bottom of a fraction and the top of a fraction, we flip it. So 1 over w plus c on the bottom, if we want to simplify that, we can move it to the top and flip it, in which case it's going to become, on the top of the fraction, it'll become w plus c over 1, or just w plus c. And we end up with w times w plus c, or you could distribute that and get w squared plus cw. Number 11, ax to the negative 1 minus by to the negative 2. Now, you're asked to subtract these, so you might have looked at them and thought, well, those aren't like terms. I can't combine them. Watch out, though. Notice that, first of all, I asked you to combine them, so they probably can be. And second of all, we've got these negative exponents here. So if we rewrite these in a slightly different way, we're going to see that we can combine them. And the way we'll rewrite them is using that rule of flipping things when we move them between the top and the bottom of a fraction. We can rewrite a times x to the negative 1 as a over x. And we can rewrite b times y to the negative 2 as b over y squared. Now what we have is we have two fractions that we're looking to subtract. And that's something that we know how to do. So we'll have to make sure they have the same denominator, a common denominator, and then we'll be able to subtract them. So the least common multiple of x and y squared is going to be xy squared. So we need to take this x and change it to y squared. So we multiply by y squared on the top, we get ay squared, and on the bottom, xy squared. Now the other fraction, we need to make that y squared into xy squared. So we multiply by x, do the same thing to the top and the bottom, bx, and then x times y squared will give us xy squared also. All right, now they have the same denominator. We can combine them. So the denominator on the bottom stays the same, xy squared. And on the top, we'll get ay squared minus bx. There are no like terms there. Ay squared and bx are very much not like terms, so we can't go any further. But that will be our answer there. Ay squared minus bx over xy squared. We can combine those into a single term by treating each of these as a fraction. Last one that I wanted to talk about, your last 4 questions that we had to do with sets. And there were a series of true and false questions, all having to do with these same 3 sets. The first one, set L, has members 0, 1, 2, 3. Then set P has the members 5, 6, 7. And set Q has the members 0 and 1. This one, there were more mistakes on than on the other questions. And I think it has to do with this symbol here that not all of you remembered. That little C, that sort of curly less than sign, remember means subset. So I'm asking, is it true or false that Q is a subset of L? Now remember, what is a subset? A subset is a set that has a set all of whose members are also members of another set. Then we can say it's a subset of that set. Now Q, the members of the set Q are 0 and 1. And L, its members are 0, 1, 2, 3. So all of those members of Q, 0 and 1, are also members of set L. So we say, yes, it is a subset of that one. Okay, let me know if you have any questions about any of these. Come to my office hours, shoot me an email. Again, you can, I'll post the answer key. You can check my grading because there were some issues there. And I'll talk to you guys soon.